Today's practical is on rates of reaction, which is one of the required practicals for GCSE chemistry. There are two different practicals that you need to know about in investigating and measuring the rate of a chemical reaction. In one practical, you can measure the rate of reaction by using the volume of gas produced, and in the second, by measuring the change in colour or turbidity. In today's practical, however, we will be investigating how changes in sodium thiosulfate concentrations will affect the rate of reaction with hydrochloric acid by monitoring a change in turbidity. For this practical, our hypothesis is that if you increase the concentration of sodium thiosulfate solution, we will increase the rate of reaction. Now, there are a few key points that we need to know about for this practical, and I would like to discuss those now. When we react sodium thiosulfate with hydrochloric acid, a product is formed which is insoluble, and it is a cloudy yellow precipitate. This is sulfur. The sulfur is what produces this yellow and cloudy mixture. This is a measurement of turbidity. Now, in this practical, we will observe and measure the time it takes for this printed black cross to disappear from underneath the solution when it gets cloudy and thick. The independent variable for this practical is the concentration of the sodium thiosulfate solutions, and the dependent variable is the time it takes for the cross to disappear from under the solution. And the control variables include the amount of sodium thiosulfate solutions and the amount of hydrochloric acid. Before we start the practical, we need to do a risk assessment. Now, we are using glass equipment, so we need to be careful about breakages. Also, we are using chemicals such as sodium thiosulfate and hydrochloric acid, so therefore safety goggles should be worn throughout the practical. Also, if you suffer from asthma or any respiratory conditions, please avoid leaning over the conical flask, as the sulfur dioxide fumes that get produced are irritating and can cause coughing. For this practical, we need a conical flask, a 100 cm3 measuring cylinder, the printed black cross which I showed you earlier, a white towel, a dropper pipette, a stopwatch, hydrochloric acid, and a small measuring cylinder. Also, we need 5 concentrations of sodium thiosulfate solution. In the first, I have 8 grams per decimeter cubed. This is a solution made up of 10 centimeter cubes of sodium thiosulfate and 40 centimeter cubes of water. In this, I have 16 grams per decimeter cubed. This is made up of 20 centimeter cubed of sodium thiosulfate and 30 centimeter cubes of water. In this beaker, I have 24 grams per decimeter cubed. This is made up of 30 centimeter cubes of sodium thiosulfate and 20 centimeter cubes of water. In the fourth, I have 32 grams per decimeter cube. This is a mixture of 40 centimeter cube of sodium thiosulfate and 10 centimeter cube of water. And in the fifth beaker, I have 40 grams per decimeter cubed. This contains 50 centimeter cube of sodium thiosulfate and no water. I have prepared these solutions beforehand so that the practical can run smoothly. So, the chemical equation for this practical is sodium thiosulfate plus hydrochloric acid, giving us sodium chloride, water, sulfur dioxide and sulfur. We can now begin the practical. First, I will need to measure out 10 centimeter cube of hydrochloric acid using a small measuring cylinder. I will use a dropper pipette to ensure accuracy. Nearly there. Remember to read from the bottom of the meniscus. Okay, that is exactly 10 centimeter cubed. Now, first we need to place the black cross onto the white tile. Next, place the conical flask on top of the black cross. After this, we need to pour in the hydrochloric acid. We will now add in a concentration of sodium thiosulfate solution to the hydrochloric acid. Now, when the chemicals are mixed, the reaction will start. So we need to be ready with our stopwatch. I will add in the concentration of 40 grams per decimeter cubed first. I have started my stopwatch. I'll give it a gentle swirl to mix the chemicals up. Now I will observe the cross from on top of the conical flask. You can see that the mixture is getting yellow and cloudy. As soon as the cross completely disappears, I will stop the watch. That took 35 seconds for the cross to disappear. Now we need to repeat this step so that we can obtain a set of results to work out a mean value. And we need to work out a mean value to obtain accurate and reliable results. We need to then wash out the conical flask and repeat this procedure with the remaining concentrations of sodium thiosulfate solution. Our results support our hypothesis. They show that when we increase the concentration of sodium thiosulfate, we increase the number of sodium thiosulfate particles, which result in more frequent collisions and increases the rate of the reaction, as seen for the 40 gram per decimeter cubed concentration. And when we dilute the concentration of sodium thiosulfate, we reduce the number of particles, which result in the rate of reaction to decrease, such as for the 8 gram per decimeter cubed concentration of sodium thiosulfate. You can also plot a graph with your results, with the concentration of the sodium thiosulfate solution on the x-axis and the mean time taken for the cross to disappear on the y-axis. A smooth line of best fit can be drawn. The line should be a curve.